Hi everyone, today I'm going to do a short, I'm going to say short, it probably won't be short by the end of it, introduction to OOP. One of my colleagues actually come to me and said, can I explain a little bit about the paradigm shift between standard procedural programming compared to OOP programming? Now, as with coding bytes and how I like to put through ideas, typically I'll do this based on coding examples. I'll actually show you something live. I've been through many courses that people have done. People have done some excellent courses, but they sometimes keep it very high level, which means it's all about concepts and ideas, and sometimes I find it hard to then apply that to real code, real situations. So with my videos, what I'd like to do is get a bit of code down there. Hopefully that gels with you all and you'll be able to see how this can be used. A place to go. Christopher Akravi, hopefully I'm saying his name right. Fantastic software engineer. A lot of my OOP experience and anything I've learned has come from Christopher. He's very good. Easy to watch. He's got a fantastic YouTube channel. I highly recommend you look him up and follow through, because once you get into OOP, you'll suddenly realize there's certain things that you want to do and need to do. And people have come up with patterns and solutions for common problems. It's one of those things. So definitely check out his site. There's a wealth of information that comes from this guy, and yeah, hopefully passing him on to you all will improve your knowledge as well. So back to the question at hand: procedural programming compared to OOP programming. Now, from what I understand, OOP is almost a natural progression of procedural programming, which is why I found, since taking on OOP in a PLC myself, I find it very hard to go back. It's almost like a method you can use to simplify your code and make things very reusable, but fits quite nicely with procedural programming. So it feels good. That doesn't obviously explain what's the difference between the two of them. So from what I understand of procedural programming, it is just a case of we're laying out procedures. We have certain steps we need to take. We have certain inputs. We have certain outputs, and we make our way in a procedure through that code, and we do things. Now, OOP is a method of taking that code and encapsulating it. And so when I say encapsulating it, it means we're going to take big lumps of code out of our big, long procedures, and we're going to try and put them into small areas, which should hopefully make the code easier to write, to read, to reason about. But most importantly, what we're ultimately trying to do with any software we write is we want to make it easy for people to understand when they come back to it, so there's less of that mental input that you need to give investment into a program to try and get up to speed with it. Because one of the biggest things that people will be doing is, say, fault finding your code. They're going to be going into your code and they're going to be reasoning what's going on inside it. So the easier we can make that job, the better. That's one of the things. One of the second big reasons that we do any form of new paradigm, new style functional programming, is because we want to reuse code where possible. So anything that makes our code easy to read and reusable is a really good thing. And you'll also hear where people say about if your code becomes too spaghetti code, it's highly dependent on other things. The minute you have high dependency in code, so some code relies on other code that relies on other code, it becomes really fragile. And in the end, you can make breaking changes. So suddenly your code will become it will stagnate because people are too scared to make big changes. And that in this world, with complex machinery, we need to keep our code lightweight, mobile, really reusable, and highly decoupled. The more decoupled we can go, generally the better, because it means that we can make changes over in one side and things just won't break on the other side. They're not coupled together. They're not gonna be impacted tremendously. I also heard as well it helps us when things change. There's different sort of decisions of when something is a changeable thing. And typically what I would do is in PLC work, I'm often working on a bit of machinery. So things that change in my world would be what I/O is used, what sensors are used, and what modules maybe the customer needs. They're always going to change. With modular machinery nowadays, you could almost argue even the process and the product that you're working on is changeable. So change is where before you was making one machine over and over again, and change was typically bug fixes, and that's about it. Now, change in this modern world, we need modern machines. We need to be very reactive to change, and this is why OOP kicks in and just allows us to do some clever things. So yeah, in that sense there, so from procedural programming, which is just making our way through a set number of procedures, a lot of the time we can get quite a lot of repetition, because if procedures need to be done more than once, we will ask them to be done more than once. It's a way of breaking a lot of that out, put that into OOP, into their own space, their own objects. We start identifying things that are objects, let them look after their own procedures, and let them look after their own internal variables, any state that they need to hold. Objects generally are very stateful, they remember things. And it's just a technique of just wrapping your code up, and hopefully by putting a boundary around the outside of them, not only do you stop people looking in and worrying too much what's inside of it, it also shields your objects from knowing too much of what's going on outside. That's something that's not really often spoken about. But typically, if things don't worry about what's inside or outside of them, and they just work in their own little bubble, they can't help but be decoupled. So there we go. There's a little bit of a ramble there, but let me start putting this into practice, and so we can actually see it for real. What I'm going to do is a little example, really small example here, and this is going to be live coding, so you are going to see me just code this up on the fly, so there'll be changes as we go. Little control panel with a start and a stop button. I've got an emergency stop button. I'm not really considering safety circuits at the moment. This is just going to be another button that we press that stops the bit of kit. And then what we've got is we've got product coming along off this thing here, and a conveyor belt. Now, the idea of this software will be all the time, this is a control panel for the conveyor. If we put it into run mode, or a run state, or some form of control, when we hit the green button, it means that any time product turns up onto this sensor here, this product detected sensor, we will run the conveyor for at least 5 seconds. And all the time product's coming, it will just keep restarting that 5-second timer. It's going to be an off delay timer. So after the last product has gone past, then we time out after 5 seconds. Things that can stop that are if the conveyor gets full, we don't want to scratch the bottom of our product. So we'll actually stop the conveyor. This actually, I'm just going to move that over slightly, because typically conveyor full sensors tend to be just on the next conveyor. Otherwise, once you stop the conveyor, they will never switch off again. So yeah, our conveyor full sensor is just on where this conveyor is delivering to. And the other thing as well is either stops or emergency stops will just kill the entire control and say, no, that's it, we're done for the time being. So simple setup. And what I'm going to do is hopefully show you probably a very raw and not really well thought about procedural version of this. And then I'm going to take you through on how I would then start making this OOP. So I'm actually going to introduce the concept of OOP to you in terms of what does it bring to the table. And therefore, if you like the look of this, we can expand more in later videos where we go through some techniques and some things that you're going to hit. But let me just start off by showing you what you get. It's slightly more code, but hopefully slightly easier to read and reusable. So behind the scenes here, you can see some code that I've just thrown together. Starting off with a GVL, we've got a stop button, emergency stop button, start button, all as inputs. We've got our product detected sensor and conveyor full sensor, and our motor contactor as an output. So that's mimics this setup here. In main, we're then saying if either of these push buttons are pressed, and what you have to look at here is typically a stop button or emergency stop button will be normally closed. So in this instance, we're saying if we don't have a signal on the stop button, or we don't have a signal from the emergency stop button, that means they've been pressed. That's typically because if you cut an emergency stop button off, the machine should react as a stop or emergency stop. So that's why we've got the nots here. We're setting a variable of conveyor control as false. That's going to be our, are we kind of in run mode, that type of thing. Next, we've got GVL start button and stop button. So that's saying if I have a signal back from my stop button, it means it's not pressed. And someone is pressing the start button, then set the conveyor control as true. So this is kind of like a little machine state as such. And then we've got this timeout. We've got a little off delay timer, and we say its input is based on conveyor control. So as long as this thing is in run mode is true. And the product sensor is true. So this product sensor is seeing product. Then we're going to have a 5-second timeout once those conditions disappear. And lastly, GVL motor contactor. We're saying, right, you will run all the time that this timeout is on. So that's going to be any time we see product. But it's ending this conveyor control. So the conveyor must be in a run condition, because if they hit emergency stops, we want that conveyor to stop straight away. And then lastly, we say and not conveyor full sensor. So as long as the conveyor is not full, we will allow the motor contactors to run. So procedural programming. Already, I find that hard to say, and it's hard to reason about. And let's say someone was to add another sensor. These conditions are going to get complex quickly. And yeah, so I can already feel that OOP really steps in at this point and says, well, have a go. Put some OOP together and see what you feel. Just see how it works. So this definitely screams out for a bit of OOP from my side, and you can, I would say, start simple with OOP as well. You can very quickly get out of control, and very quickly you're going to need to know certain patterns and ways of doing things. Keep it simple to start with, and you can get some benefits from OOP without jumping fully in. If the other thing I want to show you as well is, let's say, for example, someone had two conveyors. Now, if that was the case, we would be copy and pasting this code twice. We would change all of these to stop button 2, or maybe they're on different modules. So module 1 stop button, module 2 stop button. We'd have to go into the GVLs, and we'd have to duplicate all of these as well. So suddenly duplication becomes slightly tricky, messy. We're getting a lot of dry here. This is don't repeat yourself. That's one of the things that we try not to do. There's a lot of dry here, especially with the logic itself. A lot of you are now going to be shouting at the screen saying, why don't we use a function block? So, which is valid. Yeah, you could put a lot of this code inside a function block. Function blocks we actually use function blocks for OOP. We use them in a certain way, but a function block is definitely a way of collecting all logic together. And maybe we pass into that function block our inputs and our outputs, and we let it decide what that logic should be, and then pass out. But what I'll show you is, had we gone the function block route, it's good. We've definitely done dry, but we're still a little bit susceptible to change, because now, let's say a customer said, well, on conveyor 1, I'd like my product sensors all to be normally open product sensors, and conveyor 2, I want them to be normally closed product sensors. We either have to make brand new function blocks, one for each, or we need to condition their inputs first. So so you can suddenly say, very small change, quite not the easiest change to then implement. That's definitely going into our code and making changes. So yeah, so function blocks, but they're just an extension of procedural programming. There's a way of just really covering dry. Don't repeat yourself. OOP, we're going to see what you get over the top of a function block. So so you definitely get some benefits. Right, let's drop this back. Now, if we're going to turn this into objects, where do we start? First thing I'm going to do is start identifying some things that are objects. And these can be abstract things, these can be real life things. In this instance, this is going to be some real life things that we're going to start with first. So just in here, I'm just going to make a folder. I'm just going to call them, let's call it devices. Just for the moment, We might refactor as we go. Now I'm going to go in and make a function block, because function blocks is how modern languages, these IEC languages implement OOP. So they are function blocks. They're just used slightly differently as the standard function block. So I don't typically prefix anything anymore. So Hungarian Notion is kind of out now. I will on interfaces, and we'll get into that later. But so for the minute, I'm just going to keep this really simple, because sometimes you're going to be late night coding. You want to keep code as simple as possible, because late night coding, your brain doesn't work very well when you've got when you've shrunk down words, you've used so much prefix, it's hard to read. Just keep it simple. So I'm just going to say I've got a normally open push button. Easy as. There we go. This thing is going to be a function block, and I'm doing everything in structure text. So normally open function block, push button. It is a function block. First thing I'm going to do is remove inputs and outputs, because if I'm going to treat this as an object doesn't have inputs and outputs like a function block. An object can have methods, which means that we can ask the function block to do something. So typically a method is making it do something. Or we have properties, and that's a way of extracting out or giving it values. So we'll start expanding upon this in a moment. So there we go. So we've got a function block already. It does have internal variables, and it's a normally open push button. Now what we can do is take our what do they call it? It's our link to the outside world, our hardware link. We can actually take this now. Let's just copy this out, and I'm going to put this on the inside, and I'm just going to call this input. So we've got a normally open push button, and it's got an input at %i start the ball in. There we go. So if I was to use this function block now in my program, it will automatically come up with the input that it requires. So it's a Boolean input. So normally open push button, this one here. Let's just open this out. Now, what we can do is our stop button, instead of now working with these, which is actually going to be my start button, because my start button is a normally open push button, I can start replacing them out, which is great. So this is what we're looking to do. We're looking to make devices which starts doing away with what we already have. So we can almost call them primitives. In this instance here, our start button was a primitive of a Boolean. It's true and false. Now, just glancing back on this, that means that things like start buttons, we're evaluating them as Boolean, which isn't great, because you could argue a switch is as Boolean as it gets. That it's either true or false. But it doesn't read very well. So because if you was to say, hey, start button equals true, or start button equals false, it's not very domain language. We're not really working in a domain of a push button. It would be much nicer if we could say, is pressed? Makes more sense. We know what it is. People who are non-software engineers can reason about that. That's definitely something we can reason about. So what we want to do is, with our objects, while we start identifying objects, we also want to start bringing in some domain level language. So in order to do that, our normally open push button has an input, and where we would normally have reasoned of this of is true, is false. We can right click on this, say add, and I'm going to add a property, and I'm going to call the property is pressed. There we go. It's going to return ball, and I'm going to make it public, which means that anyone who uses this object, anyone on the outside of it, can access this. So this is something that can be accessed. Properties have getters and setters. So a property, when we come in, we can say, hey, is pressed, I want to set you to true or false. From a buttons point of view, that's not required. We're just going to use a getter. We're going to say, hey, push button, are you pressed? Can you give me that? So what I'm going to do is get rid of this set. Getters and setters are great because in setters you can also do things like checking the value that someone's given you. But we'll cover that more in more videos. This is going to be a long video already. So let me just try and keep it as close as possible. So I've got a normally open push button. It has an input, and this is pressed, when I get it, what I'm going to say is that you have to refer to this name here. I'm going to say that my is pressed is equal to my input, because my input is either true or false. Therefore, is pressed will be true or false in exactly the same way as the input is. So you can almost argue and say, well, you're kind of doing the same thing, you're just dressing it up differently. Exactly that. I'm dressing it up differently. I'm dressing it up in a way that people can reason about from the outside world. I'm taking away some of that domain level. I'm putting it into the domain of a push button. So let's see how this looks like in the main program now, because we've just broken our start button because that doesn't exist as a start button anymore. So we can now say is pressed. Now, looking at this already, else if is start button is pressed and stop button. Okay, so I would argue that's slightly easier to read now. So let's start bringing it into the stop button, because the stop button is going to, stop button, emergency stop button, they're going to win out, because at the minute we've got this whole if not stop button. Oh man, that's hard to reason, especially when I hit an or not emergency stop button. I have to, in my head, remember these are normally closed switches, and therefore this whole thing here, if you told someone, look at this bit of code, why are we doing this? They would have to know the machine first, reason that they're normally closed stop buttons, and then say, if someone's pressed stop or emergency stop, I'm going to turn off conveyor control. That was a mental leap they had to take that we can help them with. So what we can do now is this normally open push button. Jobs are good. That's it. That's good. I'm going to copy and paste that, and I'm going to now make a normally closed push button. Let's get rid of this one here. And change the name of this. It's just going to refactor it for me. There we go. So I've got a normally closed push button now. If I open this, yes, I've got an input for it. And its is pressed is going to be slightly different. And you can probably guess what we're going to do here. Is pressed is going to be equal to not input. Save. Now we can take this and replace our GVLs. So our stop button is now a normally closed push button. And let's just copy some of this out as well, because no one likes typing. Normally closed, we're good. Right, so now, funny enough, it kind of makes us our GVLs read like a parts list, which is great. So there we go. So a stop button, we know we've got a normally closed push button on there. Emergency stop, normally closed. Start button, normally open. Brilliant. Because we've encapsulated this is pressed, and we've done all that little logic of normally closed, normally open inside the object itself. Inside main, we can now use this is pressed on the stop button, on the emergency stop button, everything here. And now we can just go for our logic. So we can now say, if the stop button is pressed, or the emergency stop button is pressed, then conveyor control equals false. If the start button is pressed, and there we go, we're going to hit our first not now. Putting not is pressed, not bad. It's we could say, let's break that into its correct language as well. So again, this is live coding. I'm just making this up as I go along. So having an is pressed, I'm just going to copy and paste that, and I'm going to call this one is released. There we go. So it is released. And the code inside a normally open push button, we can refer to other properties now, because yeah, we've got this is pressed, is released. We can say is released is equal to not is pressed. There we go. So there we go. We've not even had to worry about what the input is anymore, because it's going to just be the opposite of what is pressed is. So far so good. And that means we can actually copy and paste the normally closed straight in there. There we go. That's fine. We've now got working code on both of these. So instead of is pressed, we can now say is released, and we've got rid of a not as well. How's that read? So if stop button is pressed or emergency stop button is pressed, then conveyor control equals false. Reads okay. If start button is pressed and stop button is released, then conveyor control equals true. We can now see as well that potentially we could start adding some extra things in here, because when it was complex in regards to how I'm trying to keep all this in my head, you suddenly quickly realise that you say, well, actually the emergency stop button, in a simple application like this, you'd kind of want that too. So as long as the stop button is released and the emergency stop button is released, then conveyor control equals true. Good to go. Next, what we're going to do is look at what else have we got. So we've got product sensors. Now the sensors themselves, I'm actually going to copy the open push buttons because it's almost exactly the same. So normally open sensor. I'm going to put this one in here. Just going to adapt this. And I'm just going to put is active. Okay. So let's just get that to rename. Just delete this as well. Okay. So a normally open sensor, is it active? Get is just going to be is active equals input. And likewise, we may as well we haven't got one yet, but if we were to do normally closed sensor, and exactly the same again. It's just going to rename this for us. Normally closed sensor. It is active is going to be the inverse of that, so that's not input. Okay. Now we can go off and start laying these down. So normally open sensor, GVL. This is this one here. So we're going to just push this one in. That's normally open sensor. That's normally open sensor. And we'll come back and do the contactor in a moment. Back to our main. So conveyor control. Oops, not conveyor control. So our product detected sensor is active. And this one here, timeout conveyor full sensor is active. Okay. So nothing major changing there. So you'd almost argue the work we have done, okay, it does read slightly easier. But why did we bother? What was the point of that? We've lifted the decision making, any of that domain specific thing based on that sensor, we've lifted it completely out of the main project's need to know. Because now, let's say, going back to this, that the customer says, well, actually, normally closed sensors are much cheaper now and they work better. So we're going to swap over these product detected sensors, conveyor full and product detected. As far as we have to, the changes we need to do in our program, we just go back into the GVL and these open sensors here, we swap to closed and we're done. That's it. Because is active is dependent on the object you've used. The object has now swapped out. We've just swapped out that object. It's now a normally closed sensor. The code here doesn't care about that. It just determines is it active or not, which is great. So with a very small bit of OOP, we've now introduced domain level language, easier to reason about. Next, we've now got to the stage where we can make very quick changes of things that will change often. Sensors are always changing. They have almost no impact. Okay, right, I'm just going to have a small break now, and then I'm going to come back. We're going to finish the motor contactor, and then we're going to start showing the true power of OOP and just how good this thing can get. Okay, see you in a bit.